In this video, we're going to start solving formulas for different variables within the formula, but we'll focus on formulas that have radicals in them. As a starting point, we'll start with an old example, a linear example, y equals mx plus b. So in part A, we're going to solve y equals mx plus b, and we're going to solve it for m. Hopefully we remember from past experience, if we are trying to solve for the m, we first need to identify that this is the variable we're solving for. And to solve for that variable, we need to peel away the layers that are connected to it. As a first step, we're going to need to remove the b from that side of the equation. To remove that plus b from the right side of the equation, we'll need to subtract b from both sides of the equation. And this will give us the equation y minus b equals mx. As a final step for solving this for m, we need to recognize that right now we have m times x on the right side of the equation. And so to cancel out that times x, we need to divide both sides of the equation by x. And when we divide both sides of the equation by x, we will be left with the equation y minus b all over x equals m. What you want to remember is that at any step of this solving process, you are doing the opposite of what is given in the equation. We had a plus b to begin with, so we subtracted b. We were multiplying by x, so we divide by x. This is the same solving strategy we use for any equation. Now looking at part b, we want to solve y equals the square root of x plus 3. While following a similar strategy, we need to do the opposite of what has been presented. We are trying to solve for x, which is caught up with a plus 3, and all of that is under a square root. The opposite of taking the square root of something would be to square it. So we will square both sides of the equation. On the left side of the equation, we end up with y squared, and on the right side of the equation, we have x plus 3. To finish solving this for x, we simply need to remove that plus 3, and the opposite of adding 3 would be subtracting 3. So we will subtract 3 from both sides of the equation. And this leaves us with the equation y squared minus 3 equals x. So on the one hand, what we're doing is fundamentally no different than what we did before. We try to isolate that variable by peeling away the layers of what is being done to the variable using the opposite operations. There's one fundamental difference, though, between the equation in part A and the equation we were working with in part B. The original equation in part B was y equals the square root of x plus 3. In that original equation, y equals the square root of x plus 3, we were limited both by what values we could put in for x to have that square root actually do a computation, and we were limited by what values of y could be obtained from that square root. In that original equation, any value of x less than negative 3 would have resulted in x plus 3 being a negative value. So from the beginning, x values had to be greater than or equal to negative 3. And similarly, when you're dealing with a square root, if y is equal to the square root of something involving real numbers, the only values that can come out of such a square root would have to be either 0 or positive, but no negative number could come out of that square root. So the y values we're restricted with in that original equation would be greater than or equal to 0. When we take an equation like the original one we were given and transform it into the new form, like y squared minus 3 equals x, we are still going to be bound by these limitations. The x values we work with in the new transformed equation, y squared minus 3 equals x, have to be greater than or equal to negative 3, and similarly, the y values we put into that blue equation also have to be bound by the y values being greater than or equal to 0. This is something you want to think about in the background. It doesn't change any of the work that we did, but it is important to recognize when are the square roots going to give us issues, and what values are these square roots limiting us to work with.